Okay, before we move on to look at some bigger and better things, I have a couple of topics I need to discuss. One is purpose. Why am I doing this? What is it meant for? Well, it's not meant for producing enough gas to be stored. That's obviously a real complex problem, where you would have to pressurize it or have large area to store the gas in to be meaningful. What this is made to do is when it's ramped up, it will produce enough gas to sustain a small cooking flame. And at the same time that flame is used for cooking, for example, you can charge a battery or you can produce light, as I showed in the first couple of videos. Now we'll get into this in the next video, so just kind of ignore it at this point in time. Now, another thing is, if you did any work with the diodes immersed in water in the first cells that I showed in the videos, then you found that the diodes actually disintegrated. Well, in the case of these little ferrite filters, the only reason I used them was they were convenient and I have a ton of them. But they will also disintegrate. Here's the one that was used for the cathode electrode. A little bit of buildup here on the ferrite, but the wire itself is intact with no pitting or erosion. Now it's a little bit different when we get to the anode. Here's what happened to the anode wire. It totally disintegrated, and it actually has a very sharp point on it. Now I cut this end off here, so that didn't disintegrate, but the part that was in the water actually went into the solution, and we don't want that. Now there's a couple kinds of metal that you can use that will not disintegrate, and if it does, it's not as rapid. And what I've done here is I've used some stainless steel. Now everybody ought to be able to come up with some stainless steel wire, a stainless steel spring, maybe even a couple of real small stainless steel screws that can be used for electrodes so that you don't have the disintegration problem. Some of the other metals are quite expensive and would be hard to get a hold of for everyone, so we won't go into that until some later video where I show where I actually use something like titanium. And as far as the purpose itself, realize that this particular circuit can be ramped, and what is happening on this side of the circuit is independent of what's happening on this side of the circuit. When you load up this side of the circuit, it does not necessarily impact this side of the circuit unless we're out of tuning or we have the setup improper. Now I'll go ahead in the next video and show you something about how you go ahead and charge a battery with this at the same time you're producing gas. This one is fairly effective, and I'll cover the topic of how you really know if that happens to be a phantom charge or a real charge. Sometimes it's not that easy to determine, but we'll go into that in the next video. Also, what I want to cover is how you tune these things. You've got to be extremely careful, because in a lot of my videos I use an AV plug hooked to a LED, and a lot of the other replicators and experimenters do the same thing, and the body holding the sensor forms the counterpoise, and you bring it near the circuit and the LED lights and so forth. Now if I were to hook this to one of the terminals of the battery and tune for maximum brightness, that would not be correct, because all I'm seeing is the current within this AV plug loop here and the LED. So this is not the proper indicator to use when you want to look for proper tuning when you're, for example, charging a battery. But I'll get into that in the next video. I just wanted to cover the purpose of this thing, where it's going, what it's actually meant for. It's not meant to run an automobile engine or anything like that. And the fact that we have erosion, and to get rid of that erosion you have to go to different metals for your electrodes. If you want to start out with something like this, for Pete's sake, stay away if you can from copper. That's the worst one you want to use. But if you get something that has a tin coating or something like that, it will last longer, and you won't get that horrible green mess that you get from the copper. But okay, we'll go ahead and move on and get back with the next version to show you what we're doing here with the battery.